Hello, welcome to 3.4, Equivalent Statements. Two statements are equivalent, symbolized by this double arrow with double lines. This is going to be this double line, horizontal lines like that, like an equal sign with an arrowhead on each end. So two statements are equivalent, symbolized by this symbol, if both statements have exactly the same truth values in the same places. This is also known as logically equivalent. So are the two statements equivalent? So let's look at our P, our Q, our not P, not Q, a P or Q column, the negation of P or Q, and then the negation of P and negation of Q. So we're looking at this column, which is going to be here, or this statement's in this column, and this statement's in this column. Are they going to be true and false in the same places? Let's find out. Let's do my standard setup here for having two statements. It's going to be false, false, true, true. This is going to be false, true, false, true. P or Q, just one of them has to be true. That's going to be false, no, true, 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 then false. Its negation would be false, 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 true. Maybe I should change colors for that. It stands out. False, 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 true. I'm just doing the negation of this column. And our last column is an and between these two. False and false is false. False and true is false. True and false is false. True and true is true. So these are the same in the same places, so these are equivalent statements. Now, if P then Q and if Q then P, these have the same meaning as P if and only if Q. We've seen that a couple of times. Is that biconditional? Okay, you write a biconditional statement of, if the dog is white with black spots, then it is a Dalmatian. And if the dog is a Dalmatian, then it is white with black spots. So what we're seeing here, we have a P. The dog is white. With black spots. And our Q would be the dog is Dalmatian. So what we see here is if P then Q and if Q then P. So this would just become P if and only if Q. So the statement would be the dog is white with black spots if and only if it is a Dalmatian. Now I know someone's going to argue, wait, I have a dog that's white with black spots, it's not a Dalmatian. I know. There's going to be someone out there. So that would be the combination. Feel free to post that in the discussion board if you like. Hey, my dog is black, or is white with black spots, and maybe even take a picture and post it. What the heck? Remember, you need 10 postings, at least. Okay, moving on to example 3. Example 3 says, which is equivalent to, it is not true that the dog is both wet and dirty. The statement we see here it is not true that the dog is both wet is P and dirty is Q. So P, the dog is wet, and Q, the dog is dirty. Let's look at each of the following of these. Now this one says, if the dog is not dirty, so if not P, then, no, if not Q, then not P. The dog is not dirty or the dog is not wet. Not Q or not P. The dog is not wet and the dog is not dirty. Not P and not Q. If the dog is not wet, then the dog is not dirty. So if not P, then not Q. Well, excuse me, to figure this out, one thing that can help us is De Morgan's laws here. De Morgan's law says the negation of an and, which is what we have here, we have a negation outside an and, would be the negation of the first one or the negation of the second one. So by De Morgan's laws, this would be equal to or equivalent to the negation of P or negation of Q. And likewise, the negation of an or, P or Q, would be the negation of P and negation of Q. So put the negation out here. When you distribute it through, each statement gets the negation, and the or becomes an and, the and becomes an or. So I'll let you figure out here. I'll give you a couple seconds to figure out which of these statements would be not P or not Q. And you might say none of them are. Well, one that's really close is this one here, and I would argue that an and, P and Q is same as Q, or sorry, an or. P or Q is same as Q or P. So this one is going to be equivalent to it. Okay, the next one, example 4, use De Morgan's laws to write an equivalent statement for the sentence. It is false that, okay, so right off, it is false that the printer is out of toner and the fax machine is out of paper. P and Q. So the negation would be, or De Morgan's law's equivalent would be not P or not Q. So we'd say the printer is not out of toner. Or the fax machine is not out of paper. When you look at the notes, I changed the order around a little bit here, and so examples 2 and 4 are switched. Okay. I'm going to go on to the next one, so feel free to pause if you need to pause. Example 5, what would be the logical equivalent to it is not snowing and it is not raining? So we have P, it is snowing. Q, it is raining. What we see here, not P and not Q. Well, by De Morgan's laws, what we'd have not P and not Q is equivalent to negation of P or Q. So the negation goes out front, the and becomes an or. So we'd say it is false that it is snowing or raining. Okay, example 6, write the logical equivalent. Today is not Sunday, or we have class today. So we see here, if P would be today is Sunday, and Q would be we have class today, this statement is going to be today is not Sunday, so not P or not Q, or Q, because we have class as a positive. This would be equivalent to the negation of P and not Q. So we'd say it is false that today is Sunday and we do not have class. Today. Okay, example 7. John Adams was the second president and he was not a Republican. Write a logically equivalent statement. Okay, so our P would be John Adams was the second president. The Q would be he was a Republican. Okay, so what we have is P and not Q. So the negate or the equivalent statement would be the negation of not P or Q. So the negation of a negation is a positive negation of the Q. So it is false that John Adams was not the second president. And he was a Republican. And this is not a knock on any political party. The Republican Party did not exist at that time. Now, one of the really cool things we get to look at here is example 8. We're going to show that a conditional statement is equivalent to a disjunction. This is, to me, big. We can relate a conditional statement to a conjunction. So I'm going to go ahead and pause if you need more time. And erase the board. So show if P then Q is equivalent to not P or Q. So we'll have our P column and our Q column. Then we'll have our not P, then our not P or Q, then we'll have if P, then Q. Standard setup here. That's going to be false, false, true, true. So not P or Q, just one has to be true. True or false is true. False or false is false. True or true is true. False or true is true. If P then Q. So if true then true is true. If true then false is false. If false and true is true. If false and false is still true. So they are equivalent statements. So not P or Q is equivalent to if P then Q. Okay, example 9, this is a fun one. Write the logically equivalent statement, UNR will win or UNLV will lose. It's kind of the same thing, which is the way it should be, right? So what we have here is a P or not Q statement, and that's going to be equivalent to the negation of not P and Q. So our P would be UNR will win, Q, UNR will lose. Or should I say, UNR will not win. So if our P is UNR will win, not wing, Q would be UNLV will win. This first statement is P or not Q, because losing is not winning. And then we have the negation of not P and Q. So we'd say for this one, it is false that UNR will not win and UNLV will win. Next one, negation of a conditional statement. To convert a conditional statement to a disjunction, you convert it to a disjunction first, then apply De Morgan's laws. So we can't do the negation of the conditional, we can do the negation of the disjunction as we did up here. So determine the statement equivalent to the negation of if P then Q. So the negation of if P then Q would be the negation of not P or Q, and then by De Morgan's laws, that's going to be the negation of not P and negation of Q, or P and not Q. Really, this is the answer we want. I'm going to go on to the last page here, so feel free to pause if you need to. We have a couple of examples left. Okay. Variations of conditional statements. So the conditional statement is if P then Q. The converse of the conditional. Converse means you switch them if Q then P. Now the inverse of the original conditional, this is the inverse of that original conditional, we give each statement, make it negative. So not P, if not P then not Q. And the contrapositive means we're going to make them both negative and switch them. We're going to be doing both the converse and the inverse. So if not Q then not P. And we're going to find out which of these are equivalent statements. So we're going to do our P, our Q, our not P, our not Q. Then if P then Q, if Q then P, if not P then not Q, if not Q then not P. So we have the original, converse, inverse, contrapositive. Not P would be false, false, true, true. Not Q would be false, true, false, true. So if P then Q, true then true is true. True then true is true. No, true then false is false. False then true is true. False then false is true. If Q then P, true then true. If true then true is true. If false, then true is true. If true, then false is false. If false, then false is true. So these two are not the same because of the two in the middle. Next one, if P, then not Q. If not P, then not Q. If false and false, that's true. If false and true is true. If true, then false is false. If true, then true is true. So look at that. These two are the equivalent here. And if not Q, then not P. If false and false is true. If true, then false is false. If false, then true is true. If true, then true is true. So these two are also equivalent. So using this, we're going to go to example 11. If the song is by Natalie Merchant, then it is good. So what is the converse? So A, the converse, if the song is true, if the song is good, then it is by Natalie Merchant. So I just switch them. Inverse. If the song is not by Natalie Merchant, then it is not. And I want everyone to post on the discussion board your favorite Natalie Merchant song. Okay? So C would be the contrapositive. We're going to switch them and negate them. So if it is not good, if the song is not good, then it is not by Natalie Merchant. And the other thing, can you name the band Natalie Merchant was in before she went solo? Okay, that's two things you can post. Okay, feel free to pause if you need to. I'm going to go on to example 12. It's our last example. It says here, let P... It didn't give instructions. We're supposed to find P then Q, Q then P, and all that. So P, the number is divisible by 2. Q, the number is divisible by, P, the number is divisible by 4. Q, the number is divisible by 2. So we're going to find if P then Q, if Q then P, if not P, then not Q. If not Q, then not P. So if P, then Q. If the number is divisible by 4, then it is divisible by 2. That's a true statement. If Q, then P. If the number is divisible by 2, then it is divisible by 4. If not P, then not Q. If the number is not divisible by 4, then it is not divisible by 2. And finally, if not Q, then not P, if the number is not divisible by 2, then it is not divisible by 4. The ones that are true, the first one and the last one are true. The two in the middle are false. Well, that'll do it for 3.4 equivalent statements. So send me your questions. I hope you guys enjoy this. I hope you learned something here. I always hope you learned something. So have a good day. Bye.